Hello, and welcome to the Fundamentals of Weather Spotting and Observing in the Inland Northwest. This is the first part of a series of videos talking about weather spotting across the Inland Northwest and based on a virtual spotter training held on June 21st of 2017. During this video, we're going to cover several different topics. In each video, we're going to have an agenda that covers the background of the National Weather Service and its tools. The next one will talk about spotter reports. The third one will be about severe weather 101 across the Inland Northwest. Then next about cold season weather. And lastly, different ways to get involved and volunteer for the National Weather Service. The National Weather Service office in Spokane is located west of the city, actually west of Airway Heights on the West Plains. At the office, we have about 26 employees, most of which are meteorologists that are forecasters. We have one hydrologist that monitors the rivers and several technicians that keep our machines working smoothly. Our office is staffed 24 hours a day, 7 days a week, including weekends and holidays. Our main duties include taking weather observations, not only at the surface, but aloft with our weather balloons and monitoring the radar. We also issue forecasts out 7 days, and these forecasts are issued twice a day with updates as well. In addition, with our radar, we monitor severe weather and issue all weather watches and warnings for the region. The Spokane office is one of 122 weather forecast offices across the country. In Washington, Spokane is surrounded by the Seattle office, the Pendleton office in Oregon, and the Missoula office in Montana. Each area covers several counties. For the Spokane area, the counties span from the Cascade Mountains eastward to the Montana border, and then from the Canadian border to just outside of the Tri-Cities. This is called our forecast area responsibility. Across the Pacific Northwest, terrain makes all the difference when it comes to weather. Most of the weather comes from west to east, with storms tracking across the Pacific, carrying copious amounts of moisture, and then running into the mountains, with the first range being the Olympic Mountains, and then the Cascade Mountains, and then across the Selkirks to the Bitterroots. And by comparing what the topography across the region looks like, you can also compare it to the map of the average annual precipitation and pick out where the mountain ranges are across the region. You can see how heavy precipitation falls in the Olympic Mountains and the Cascade Mountains, and how across the Columbia Basin it's practically a desert with precipitation less than 10 inches in some locations. The National Weather Service uses many different types of tools for the observations. At the Spokane office, we do launch weather balloons that gathers weather data aloft and above our heads. We also use weather satellites to collect data on storms and where clouds are moving. And we also have our Doppler weather radar, which is right next to the Weather Service office. Weather balloons at the Spokane office are launched twice a day, every day. We fill up a large balloon and attach it to a box that collects weather data. This box is called the Radiosonde, and in it has a thermometer, a barometer, and a device that measures the moisture in the air. It also has GPS that allows it to be tracked to find out what the wind speed in one direction is. The Spokane office is one of 92 offices across the country that launch weather balloons. So these balloons rise about 100,000 feet high in the sky through the atmosphere about 19 miles, collecting weather data as it goes up. The entire trip takes about an hour and 45 minutes until finally the balloon expands so much that it will pop. When it does, the box and the remains of it will drop down to the surface, and there's a parachute that will open that will slow its fall. And here's a chart that shows the weather data as it's plotted as it goes up through the atmosphere. Weather satellites are another tool that is very important for forecasters. These devices are launched into space by rockets and put into orbit. Some satellites travel in an orbit and take pictures from pole to pole. These are called the polar orbiting satellites. Others are parked in an orbit that is very similar to the Earth. These are called geostationary satellites and take pictures from space of the clouds on Earth. We're really excited to use our newest satellite. It is called GOES-16, which is the geostationary satellite number 16. The pictures from this new satellite show quite a definition and an improvement in past satellites. And this new satellite shows many different channels and different things to look at across the atmosphere. At the Spokane office, there is a Doppler weather radar, and this radar is very useful to detecting precipitation in the atmosphere. It is one of 159 radars across the country. How the weather radar works is it sends out a pulse of electromagnetic energy, and what it bounces off on are raindrops and ice crystals. These pulses are rotated in a circle, scanning the skies, and it takes multiple slices at different elevations. Each new volume scan runs every 4 to 8 minutes, and that's when we get our new weather data on our computer screens. The weather radar is quite an improvement that we've seen in detecting storms and precipitation, but there are some limitations. The best effective range is about 90 miles with maximum distance of about 140 miles. Its lowest slice starts at about 0.5 degrees, so at distant locations we may be missing parts of the storm. And we do get ground clutter issues from mountains and trees nearby. So it's very important to have trained weather spotters. And why is that? Because our radars can't see all the things in the atmosphere. We have some locations that don't have good radar coverage, especially across the northern Cascades and parts of the western Columbia Basin. So these radar limitations make it very difficult to spot some severe weather. Weather-trained spotters are very important to fill in the holes not covered by observations. And weather spotters are very important to provide ground truth on storms as they pass. We have many spotters across our region already. Most of them are focused in bigger cities, but we'd like to have more weather spotters in more rural areas as well. So weather spotters are very important. And this concludes our first section of the National Weather Service Virtual Spotter Training. Please stay tuned for Part 2.